Alright, so here we have the actual formal notation for derivative, f prime. Again, it means slope of the tangent line. It means instantaneous rate of change at this x value. So what we're ultimately going to do is find the derivative and plug in 0. You're not going to see any inverse trig functions on a worksheet or a quiz, but I'm just going to use this one because this one is actually more simple than some of the other ones. So what's the derivative of inverse cotangent? It is actually on one of the sheets I gave you guys. Anyway, we are just going to use the product rule here. So the first function we'll call A, second function we'll call B. Remember, it's A prime B plus AB prime. Here's the derivative of inverse cotangent. It's actually just negative 1 over 1 plus x squared. It's kind of weird how the derivative of an inverse trig function is just like a rational function. It's very strange. And then, of course, the derivative e to the x is e to the x. So when you plug that in, you get a prime b plus ab prime. Nothing different there. And you really don't have to simplify this. You can actually just straight plug in the x value. The x value was, what, 0? Now, when we go over inverse trig functions with pre-calc, I will probably have you guys come along. But here's the thing. Cotangent never equals 0 on the unit circle. Why is that? Okay. Oh, it should be pi over 2. Sorry, not pi over 4. Pi over 4 is 45 degrees. So I was wrong. It's not undefined. Cotangent inverse of 0 would be wherever the x value equals 0, since it's x over y. And one of those will just be pi over 2. So let's simplify this out. Let's look at the left here. You're going to get negative 1 over 1 times 1, right? Because e to the 0 is 1. So on the left, you're going to have negative 1. On the right, e to the 0 is 1, so it's going to be negative 1 plus pi over 2. I'm just going to approximate this. We know that pi is 3.14, right? So 3.14 over 2 would be like, let's just going to approximate, about 1.6, just approximating. And negative 1 plus 1.6 is 0.6. So what does that mean? If we look at the tangent line of this graph at 0, it should be about 0.6. If we want to really simplify 0.6, we could basically say it's going to be approximately 3/5. It's going to be the slope. So let's graph it and take a look and see what it looks like. It's going to be about 3/5 if we were able to graph it. So basically what we would do, we would go up 3 and then over 5, something like that. So the tangent line would look about like this, have that slope. So that's it. On the worksheet,